think this is how you spell it. Precession. Precession is a phenomenon in the solar system for our Earth, and what it essentially is. Let's review how the Earth goes around the sun, like we learned in Hey Honey, How Are You? Today we're going to talk about precession briefly. Thought I would shoot something to see if it's usable at all. Precession. Yeah? You know that the Earth is tilted at an angle at 23.5 degrees. That's why we get seasons. So as the Earth goes around the sun, if we're on the northern hemisphere, around July, we'll experience summer because we're tilted inward when the sun's rays are more direct. And in the wintertime, we are at perihelion. But if you can imagine, there are stars all around here, right? All around here, there are stars everywhere. So what do you see as an observer out there looking up? This is the North Pole, the axis at the north, and that's facing Polaris. That's our North Star. It's called Polaris. How you find Polaris, right? You go to Ursa Major. That's the Big Dipper, and Ursa means bear, so that's Big Bear. You go to the last two stars of the ladle, and you connect them. This is not exactly how it is. I'm just going to draw this off the top of my head. Say it's something like that. You take these two stars here, and you draw an arrow here, and you'll find Polaris. I don't have the setup for Ursa Major and Ursa Minor in my head right now, so this could be upside down. That could be upside down, so don't quote me on that, but this is Ursa Major, Ursa Minor. Big Bear and Little Bear, right? And that's Polaris. So if you're on the North Pole and you look straight up, you'll see Polaris. And if you do long shot, I'll teach you how to do astrophotography. But if you do long exposure astrophotography, you'll see star streaks as the Earth spins. The stars appear to make streaks, except for Polaris, which stays right in the middle, and everything else goes around it, like that. So that's our North Star and the North Pole. The North Pole is in the Arctic. What does Arctic mean? Arctic means bear, and so Antarctic means opposite the bear. That's why it's Antarctica. It's in the opposite side of the bear area, the Arctic. A little bit of etymology there for you, if you want to help remember why these things are called the way they are. Okay, so our North Star is Polaris. I can always find the North Star. It's a good anchor star for you. And the reason why I'm doing this lesson for you is not because you need to know any of this. Once again, it's about the properties of it, what you can learn from it philosophically, and your true place in the cosmos, yeah, which most people don't know about. Which is that the Earth, because it is oblate, which means it's wider around the sides, just like me, it is not completely uniformly spherical. It's wider on the sides and shorter on the top. So it's wider on the sides. And so that forces the forces of gravity from things like the sun and the moon to pull on the Earth differently and not equally. So what happens then as the Earth spins, just like a top spinning, the axis of it will eventually make a rotation like that in the sky, will make a conical shape in the sky. If you were to extend the axis out, you'll see that you're tracing a circle. And I can give you an example of that. Right? Let there be light. So this is the Earth. It should already be at a 23.5 degree tilt. Where are you? If you're born in America. Right there is your North Pole. And that's facing towards Polaris. And the Earth goes around the sun like this, right? So you don't really notice anything changing. But with enough time, and so that's why I did the Cosmic Calendar episode, because it's about things outside of us, larger than us. We're like a butterfly that flaps its wings for a day and thinks it's forever, thinks it's eternity. But when they built the pyramids, the North Star was not Polaris. That's about 2,000 to 4,000 years ago. It was not Polaris. It was a different star. And that's because the axis here, if I could extend it out, is making an arc in the sky like that. It's like tracing like a cone in the sky. That one rotation, however, takes 26,000 years. So it's so small that only the most acute observer can really notice, and you have to notice micro shifts in stars, and you can extrapolate, well, that over a couple hundred years, couple of 1,000 years, what would it look like? And what we've learned is there's a small movement about the axis that's happening over time that is not easy to observe in your lifetime of 100 years. But if you do the math, you'll see like enough of movement that you can be like, wait a second, That should be a lot different in 1,000 years, a couple thousand years. So 26,000 years divided by half, 13,000 years. This is how the Earth is going around the sun right now, facing the North Star. It will be eventually turning like that. That's 6,500 years. And it'll be like that. So now the North Star should be completely different. I think it might be Vega, which is one of my favorite stars. It's an obvious one to pick as a favorite because it's very bright. I think Vega's at the halfway point of that. But also you remember that aphelion and perihelion from years ago when I first dabbled in this channel. So during winter, we're actually physically closest to the sun. And in the summertime, we're actually farther away, despite it being hotter in the summer. But 13,000 years from now, our winter will be here. And so it'll be hot. I have to remember how all this works. Yeah, we should be closer. So our position in the cosmos will be here in summertime. And our axis will be facing inward. So we'll both be hot because our axis is facing inward, and we're physically closer to the sun. And if you're in the northern hemisphere, that's going to be a very vicious summer. But the month will be the same, by the way. Like, it's not like that'll be like a hot January and a cold July, because our calendar already makes up for these small changes year by year, and we add it to the calendar. So it'll still be a hot summer and a cold winter because the calendar is keeping up with the discrepancy each year. But your position will be different. You'll experience summer when your position is here, and you'll experience winter when your position's here. And it's also why, it doesn't take much to disprove astrology, and I've changed my mind on astrology just because one of the lessons, or like the biggest lessons that I have for you, which are coming down the pike in a couple of months or years, it's about, what the point of us learning all this is, and, forgiving humanity and having some rules for the human race and for yourself, for me, for each other, which is that, when I was younger and like an angrier young man and way too logic-based, I would say, I would never get married to somebody who believes in astrology. But then as you get older and you just see the humanity, you go, it's a cute thing. Sure, if you want to believe it, go believe it. It's just like a fun thing, like maybe like an open lie that you say to yourself, and it's just a fun thing, and you have your own rules for that. If somebody's taking that seriously, no, they're not in my camp, obviously, but if it's just a fun thing. And just like with all these religions or anything, most humans need something larger to believe in, because it's very scary to think that you're on your own out here. And it's very hard to say the truth. It takes a lot of courage. That's a hint, by the way, for that video on how to be smart and like what it means to be smart. That's a little hint for you that I came up with in my definition, which I'll reveal later. But it takes a lot of courage to say the truth, because it might be self-defeating. Despite yourself, the truth might harm you and the story that you have built up. But you and I, or at least I am, and if you choose to join, we are both just observers of data. Our personal opinion or our wishes aren't allowed in this. And then we have a separate camp. If you want my personal opinion or my wishes or my beliefs, I can also give you that. But for this camp of us just being observers, most people just can't say the truth. So they'll make up a story to believe in. So if it's astrology and they want to believe in that, sure, whatever. I have a friend who sends me a new one every day, and she goes, I know you hate this, but she keeps sending me it every day. I was like, you know what, that's cute, fine. I'm not superstitious, but there are very smart people who are like a little bit just for fun. It just makes you feel better. That's okay. That's your biology. I don't need any of that, but if humans need it, I forgive it. And my rules for that, which I've already made up, which we'll go through in another episode, is as long as it doesn't harm somebody else. You can make up your own story, but if you're harming somebody else through that story, that's when I stop in with the hand of God, and then you'll see God. But we'll go into all that in another one. The first several episodes are just data and a little bit of philosophizing, and then the end we'll get more serious into how to think and what to think and why I have certain rules the way that I do. They're all born from the facts that we have agreed upon, that we know to be true. You remember from the James Webb episode, I must have covered it in that. I'm nervous to go back and look at those kind of videos, but when we launched James Webb, it was worth it for us to ship it, remember, without announcement, all the way to French Guyana. Here, it was worth that risk. Why? Because the equator is moving faster than anything north of it or south of it. So you get free velocity already just by being here. So when you launch, you already have that added velocity to your launch speeds. If you launch here, it's almost zero. You're just launching with your launch speeds. So you get free velocity here, that much more, which means that much less fuel you have to carry, things like that. So the Earth is not uniformly spherical. It is actually fatter around the waist, just like me. Okay? That is a precession. Yeah, oh, so why I mentioned the astrology thing, it's because the stars that you see at that time, even though I said in winter time, you'll be in a different position, the month will be winter still, and you'll be farther away and you'll be pointed away. Yeah, you'll be pointed away because because the calendar is catching up, but you're in the opposite position 13,000 years later. It's why I'm saying that is because the stars that you see, which are what astrology is all based on, your Taurus, Gemini, Aries, or whatever, those are going to be different stars. So if you're born a Taurus now, which I am, I guess, you are not that. You are the opposite of that in 13,000 years. And every couple thousand years, it'll be different in the night sky. It keeps moving. So it's not the same signs, astrological signs, or whatever that is, that you have now. And the point of me even saying any of this is just to give you, like, these first couple of episodes, that the thing to extract is that you can look myopically or less myopically. And I think that'll behoove you on how to operate and how to conduct yourself and what expectations you have from others and the rules you set for your life. And it'll sober you up and help you be efficient and live the life you want to live. A good, happy life that's vested in truth and discipline by rules that you made up, not me or anybody else. You made up based on your knowledge of the truth. You go, well, if this is true, this is how I want to live my life. This is how I want to treat others. This is how I want to treat myself, things like that. That's the point of all this. So most humans you see are just in their thing. So they think that's always there, but that Polaris will not always be there in that position. That'll not always be the North Star. And you and I know this, and you and I know why. I think that's a good thing, right? So one of two things that finally helped unlock my theory of everything was anthropology, because of the scale of time. And so that helped, just having that scale, being like, okay, it's not just about these 70 or 100 years that you get here on Earth. It's about what came before you, and the ratio of that with other things. And also then you can make predictions for the future too. That's why I did that cosmic calendar episode for you. Okay, so precession is because the Earth spins about its axis, and it's oblate, which is wider at the sides. So gravitational forces from the sun and the moon and other planets affect its axis such that it spins and it carves out a cone in the sky that you can't see, and it's making a circle in the night sky. So what is our North Star there? Even though we're moving about the sun like even though we're moving about the sun like this, with enough time, eventually, see how my axis is? This is huge unscientific arcs, okay? Eventually, with enough time, now I'm at 13,000 years later. So it's a different North Star for those people. You won't be here, I won't be here. Maybe we will be, we'll see. But no, statistically no. It keeps going, until finally, 26,000 years later, I believe, it's back to the North Star, back to Polaris. What will be interesting to research there is how that much time affects the positions of stars, right? In 26,000 years. How much will Polaris have moved in relative to our star and the other stars? We can investigate that. See, these are the logical next questions that you can investigate on your own, get an answer, draw conclusions from, things like that. This is how to think. You ask logical next easy questions, as if you're a kid, as if you're like a 5-year-old to ask these questions. It just gets like beat out of us during the school system, where these natural born scientists, as Sagan used to say, stop. Like around junior high, they just kind of stop being natural born scientists. But you are a natural born scientist. Everyone is. Humans are always curious, and they're always testing hypotheses and drawing conclusions and then updating those conclusions based on new tests at new times. You're just a natural born scientist. Yeah. So, all right. That's all I got for you today. I had a meeting that I asked to say no to 3 times. I said, I don't want to do this. I have no interest, zero interest. I don't care. And they said, could you please do it? I said, okay. So I spent last night and this morning getting ready for it. And this morning I did it. And it was good. I think it was good. But I just don't really care for these meetings anymore. I just want to focus on you and me. All right, babe. All right. I'll talk to you. Have a good day. Hope you're having a good day. I love you and I love you. And see you on the next episode. Bye.